Right. Good afternoon. I'm sort of between you guys and lunch, so I'll try not to take too long. I will start. Some of you may have seen the first few slides of this, but some of you haven't. So I'll start with maybe a little bit of history. Setting. Well, this is Europe. We're still in Europe. Up at the top of Europe, there's Scotland, and you know where you are. Sort of on the west coast, now this might be a little bit less familiar, near Skye are some islands and some sea lochs, and the story sort of begins where that red circle is in Loch Hourn. And if you look at it, it looks sort of like this. There are two villages, Arnisdale and Corran, and they're pretty small. One of my colleagues, Peter Buneman, has a house there, the old schoolhouse, and about 10 years ago or so, he decided he wanted to have internet access, and found that this was 9 miles of copper from the nearest sort of slightly larger town, Glenelg. Barely good enough for 2400 baud modem. Never mind, DSL or any sort of thing like this. Some people often try to suggest that satellite might be a useful thing to do in this sort of environment, but there are hills and it's pretty far up north, and most of the satellites are pretty far to the south, so that doesn't work so well. So what do you do about this? The very first thing Peter tried was writing letters, and he wrote letters to BT, and he wrote to Brendan Dick, and he wrote to the MPs and all these sorts of things, and basically nobody could help. So luckily, he happens to be a professor at the School of Informatics, and convinced some people in the networking group to lend a grad student to go and build stuff. So this, keep in mind, is about 10 years ago or so. So they started building this small network there, tried to make a fairly long link to where there was a DSL line. This expanded fairly quickly, and it was done. Actually, it was originally done with your favorite old Linksys WRT 54G in Tupperware containers at the very beginning. That turned out not to work so well, especially if they're put under the roofs, because the sort of slate tiles get wet and block signals. So they did a little bit better. Open WRT and Quagga, and built a ring running OSPF around this. Managed to negotiate from the nearby University of Highlands and Islands College to have some upstream bandwidth, and that was very nice, and that served fairly well for a long time, although they themselves were bandwidth constrained and started causing us some pain later on. People nearby saw this, the small isles, Egg and Rum. They said, oh, well, this is cool. Okay, well, we'll go and build this. And then, Neudart in the next block does this, and on and on. Whole bunch of these networks started proliferating on the west coast. This is about the time that I became involved, maybe about 5 years ago or so, and I looked at it and I saw, well, we've got these things. Actually, I'll skip to the map. I said we've got these networks, and first of all, they're all different. Right? They're run by in the top right, is this? Yeah, it must also be right on those things. The top right corner, is a Tegla network, and this is a ring, and it runs OSPF and those sorts of things. In fact, there are two of them, which turned out to be quite nice for research and students and these sorts of things, because, rather than being a test bed in the lab, this is actually a real network that has the shape of a real network and behaves like a real network. But, there's the one in the bottom left, which at the time, this is much different now, this is a number of years ago, at the time was a big flat broadcast domain, because that's what seemed like the obvious thing to do to the guys that were there using the similar sorts of equipment. And then the one in the bottom right is static routes. Point is, they're all different. So it's obviously a good idea to try to connect these things together, because then they can help each other, and they can, if somebody's upstream bandwidth fails, they can, you can have traffic pass through another one. But it's sort of not a good idea, I think, and we were talking about this a little bit yesterday. It's not a good idea to sort of directly connect them together, because they are all different. I mean, you don't want to have one sort of giant OSPF network or something like this. So what do? You encapsulate them in autonomous systems. It turns out that the equipment that is commonly used for radios in these kinds of networks, because these are links over water, and undersea fiber is difficult and expensive, so you've got no choice but to do radios. Sometimes they're good as radios. They're very bad as routers. Don't try to use them as routers. Just use real routers as routers and treat the radios like transparent bridges. It is very important because these are very rural locations, right? If you're sort of going directly and driving very quickly, it still might take you a day to get to one of these places. So if something goes wrong, you don't want to have to ship somebody in from Edinburgh, Glasgow, or London, or something like that to fix it. You want the people there to be able to do this, which means they need to understand the infrastructure around them, and their understanding of it might not be the same as my understanding of it or people in this room's understanding of it. So you have to, you sort of have to work with that. You can advise them, and you can say, it's a good idea to build your network like this and to not do that. But, ultimately it's theirs, and let them do that. So this is another good reason for encapsulating these things in autonomous systems, because it gives you a natural place to have that sort of boundary. However, these, of course, are much, much smaller scale by a couple of orders of magnitude than we're used to seeing with these kinds of networks, and with things that are autonomous systems generally, and also in terms of address space, because there are some of them, but few of them that even have a /24 that they could use and be visible on the internet. Most of them have smaller blocks of addresses like this. So we saw this, did that there, and people down south in the borders started doing something similar, right? They looked at that, although we got to sort of be involved a little bit from the beginning to organize them together. I said, well, okay, why don't we do this properly? Why don't we get, join right, get an AS, get some addresses, get some transit, get some peering, do this sort of thing, create something called hubs, and put the networks behind it, right? And so allow that sort of structure that was on the previous slide, hidden basically behind this AS as far as the rest of the internet is concerned. This worked very well. It still works very well, except, so these, this stylized diagram, two of these small networks. When people start building these things, they think, I want to build a network, I want internet access. What they don't necessarily think of is, well, actually, I might want help from my neighbor. And I might want help from my neighbor, and if that's mediated by a transit provider, that can be inconvenient for seeing their management networks and sharing these sorts of things. So actually, in some cases, and this red star I may come back to if there's time. Sometimes they actually are operating a network that's in one sort of area, or actually in two areas, and they can't directly connect it, and they want to be able to, basically lease a circuit to do that. All of these things actually need to be able to do things at layer 2. It can't be treated just as having a transit provider and connecting these guys to the internet. It's actually not quite so simple, though it isn't obvious to when you started doing this. So okay. Meanwhile, BT got given a pile of money by the Scottish government, and as we learned yesterday, bought giant televisions. No, but to be fair, this map on the right hand side shows they were going to build like a fibre backbone throughout Scotland, and this is great, right? And actually, as far as I know, I don't know how much of this actually is in the ground. I think quite a lot of it is, and it's good and it's useful, and a lot of that fibre wasn't there before, and it's making things that were not possible before possible. However, I don't know if you can see in the picture, but it's a network diagram. There's some lines and there's some sort of circles where the lines join each other. I looked at this, and this is again a couple of years ago before the build started, when we were trying to plan what we were going to do and how we were going to grow and such. I say, well, I wonder what those dots are. are those places where I can get Ethernet services. It would be good if they are, and it would be good to know if they are. So I did a Freedom of Information request. In fact, I did two, because the sort of western half is run by one agency called Highlands and Islands Enterprise, and the eastern half is, funded by the Scottish Government. And I said, well, okay, what are these dots, or particularly where can I get at Ethernet services? And one of them, I won't tell you which is which, one of them gave me a response that was wrong. And one of them said, no, this is commercially confidential. We cannot tell you where you can buy Ethernet services that we just paid £500 million for. So, but anyways, maybe this is actually really good news. Maybe BT is going to go in and give high-speed internet access to everybody, and we'll have nothing to do. Maybe we'll go home. Turns out that's not the case. Is that good news? Is that bad news? I don't know. So, okay. So we thought, well, fine. We were going to sort of try to take what we learned in the south of Scotland. It's sort of an evolutionary process of doing this, right? So we did this stuff up north, and we learned some things from that. So we built the stuff in the borders better, and then we said, well, okay, we'll do another iteration up north, and maybe we'll be yet better. Meanwhile, there are yet more of these small networks appearing there. And we said, okay, well, we're going to build this network up the Sound of Slate, and it's going to do layer 2 services only, and we'll use this as building blocks for connecting people. And each of those dotted lines that may or may not be visible, I hope they are, sort of is the boundary of one of these networks. And we'll do it with, just make a nice layer 2 network, use VPLS and these sorts of things. On top of this, why don't we, and now this is, I'm not, to be perfectly honest, sure that this is the right architecture for this. It's one possible thing that can be done, or maybe it's, sort of a network engineer turned academic, just sort of playing with the structures you can create in these networks. I'd be actually very interested in knowing whether this is actually a good idea. It's possible. It works. So why don't we make a point to multipoint VPLS over that network there, connect everybody to it, use the typical rules, get an IXP allocation from RIPE, which we have and it's running, and do the root server, anycast DNS, all these sorts of things, with the exception that, unlike most internet exchanges, actually, there's smaller address blocks that are floating around because the networks are smaller. And transit over the exchange or over a dedicated layer 2 circuit over the exchange is sort of the typical arrangement because, well, there sort of is no other choice. And it sort of moves some of the complexity in connecting all these guys together sort of into the center, where we can deal with that. And actually, the connection to this is quite simple, right? It's a bit of a there's a template of a few lines of config that you have to do this, and it just sort of works and doesn't really need to be touched. So we built this. And great, it works. All these networks are fully connected, so they can all exchange traffic locally, and they can, in principle at least, make voice over IP calls when the rest of the internet falls off the earth. The configuration from their point of view is completely uniform, and we can make layer 2 circuits as we need for flexibility and internal links if we need to, and these sorts of things. Great. Well, connecting all of this to the outside world involved a circuit from Mallaig to Pulse and South Gyle in Edinburgh, and this is a BT circuit. And it took a surprisingly long time to be put in. And actually, the surprisingly long time was not the bit of the circuit that went from Edinburgh to Mallaig. It was actually the bit of the circuit that went from Mallaig Telephone Exchange to the Mallaig High School, which is about a mile. And it involved things like, I suspect contractors going to do site surveys, and maybe they didn't want to drive down from Inverness or something. They say, okay, yeah, it's probably fine. And then somebody comes and looks at it, and oh, it's not fine. And oh, sorry, the capita procurement for the public sector network has gone off the rails, and so all of those things are on hold, and we accidentally put yours on hold too, and so on and so forth. It's like this kind of thing, right? I mean, not actual things that shouldn't be actual problems, but sort of are. Another important link in the network is from Mallaig to Outaseg, and this is important for actually reasons that we'll see next. This is actually, we got some, after I made these slides, we got some hopeful news that might actually come in at much less than a year. But we'll see. But it's a little bit worrisome. It takes actually a really long time to get tails. It's not the backbone network. Actually, the backbone network they built is great. It works. It's just getting the local fiber tails. It's really difficult. We have a problem, though, that is sort of much more interesting on some of these wireless links, and is a good reason why, we really want fiber where we can. We don't really want wireless. We don't want copper is old and cruddy and long. Really has to be fiber in these places. We'll see. And then the star. What time is it? It's not really there's not really enough time for the star. Well, there's a little bit of time for the star. So the star was earlier on about internal links in networks, right? So you run a network. You expect it to be one thing. You don't like when it's partitioned into different bits. Sometimes you're constrained by geography, and it has to be partitioned in different bits because there's like a mountain in the way or an ocean or something like that, and you deal with that. But sometimes it's partitioned into different bits because there is a really strange interpretation of some sort of a European rule called state aid. Now, I don't know, some of you may have had nightmares about state aid. You may or may not know that I'm told that this is a British invention that was designed to save the auto industry. And this was upset about the French and the Germans subsidizing their car industries, and this was no fair, and so we made a rule that says the government is not allowed to unfairly subsidize things because it distorts the market and harms competition and so on and so forth. And obviously that did very well for the British auto industry. And the way that this rule is being interpreted now by the BDUK and subsidiary organizations that are responsible for funding infrastructure builds in rural places says that you cannot fund the same place twice, which means that there is one organization that basically has first choice of what places are going to be built to, and whether that actually happens or not actually happens is a different question. But then everybody else, if they want to have government funding for doing this, they have to make do with what's left over. And they are actually not allowed to compete. So much for rules designed to promote competition and prevent market distortion. But basically what happens is, in some of these places, they are actually forced for completely unnatural reasons. I mean, it's difficult enough to deal with the remoteness and the topography and the problems such as that. But yet the networks have to be, in some cases, not all cases, but in some cases, structured in a completely unnatural way. And we help out with that as best we can, having the backbone network where we can make layer 2 circuits to put in a link between two places where otherwise it wouldn't be possible to, because it would mean crossing somebody else's territory or something. Some of these projects have survived that process and this has worked. Some have basically given up in the face of it, which is a shame. This, however, is actually far more interesting than all those things which are basically bureaucratic and political problems. This is one of the links. You can see up there where where the orange line is high. This is a link that's doing pretty well. That's about 250 megabits per second. It's great. It's solid. And then it kind of drops down to the measurement there is in decibel milliwatts. But when it goes down to the bottom, that means your capacity has gone down to about 40 megabits. This link actually is lucky because it at least survives with something. Some of them just completely disappear. And the green line, of course, is the height of the tide. And so the last slide, I thought there should be maybe one. I'm giving this talk from the university, so we should have one Greek letter or something in here. The reason this is happening, some of you will know this, some of you might not know this, is, well, you know, you've got a link between these two radios, and that's great, and there's a path directly between them, and there's another path that's reflected off the water. And depending on how long the path that's reflecting is with respect to how long the direct path is, you might have constructive or destructive interference. And the problem is the length of the reflected path changes because the water moves because we have the tide. And there are actually things you can do about this. You know, if you use spatial diversity with antennas, place them at different heights, and you can calculate how far apart they should ideally be. You know, you can get it so that the signal at one antenna is bad when the signal at the other antenna is good, and vice versa. And so it sort of works. And some radios deal with this well. The standards-based ones don't. The non-standards-based ones don't really. The proper kit. This is a common problem, and this is, you know, there are sort of standard industry solutions to this, but the kit that does it very well is way more expensive than the, you know, maybe £200 or so that was done on this one. This is not a backbone link. This is a guy's house. This is a guy in West Neudart. But you know, that sort of works, and this is this is why we need the fibre to RSA, and I hope it goes in soon. And yeah, I think it's oh right. The whole idea of doing internet exchange points in this style, we made a paper about that, and you can read that. And I would, you know, honestly, I would love to have some feedback about whether this is a good idea or not. And thank you. Questions?
Yep, some tidal feeding in the audience, I think. Okay.
So it's not a technical question, but
yeah.
do you think creating networks like this can increase the number of people living in the Highlands and Islands? Does it really help people work remotely?
Yes, we've seen that. We've seen villages that have not had that have had a declining population and have not had any new houses or anything built in them for 50, 60 years. Have had people start to move to them and build houses and work from there and telecommute and these sorts of things. Yes, absolutely.
Yeah, Rebellis, I see. What sort of radio technology and wavebands are you using on the cross-water links? I mean, sort of in terms of frequencies and is it licensed, unlicensed?
Those are mostly unlicensed 5 gigahertz links. This project was originally spec'd to use licensed links for at least some of the more important ones, and that didn't happen for reasons.
Given the RAF's activities in the area, do you not have any problems with the radar avoidance in the 5.8 gigahertz band?
It does cause problems. In fact, colleague Alistair there, who's shaking his head, was nearly pulling his hair out last week because of that. Yes, it's a problem.
And 5.8 gig stuff in London and other cities, and yeah, it's quite challenging. Using unlicensed bands for this sort of stuff.
The biggest problem actually is bad implementations of radar detection. Because you will find. I mean, this is where you have to start becoming an expert on. Well, this firmware version works, and this one is broken in that in that version, and having a very detailed sort of knowledge of that sort of thing. Because actually, the radar detection is sometimes just completely buggy.
Phil Corbishley from Gamma Telecom. Again, it's questions on the radio side. The white space guys, 802.11AF, have done a lot of work in this area, in rural areas in West Africa, and got fairly good results over 3 or 4 kilometres. I'm picking up the radar point. The 802.11AC guys have been working with the SCC on various mechanisms for listen before you talk in this area, and have a secondary transceiver, only costs a few dollars, which you stick it in the access point, which actually stops the system working if it detects any signals in the radar spectrum. Yeah. So there are some off-the-shelf solutions now, and of course they're going to sort of cloudify the database for all the radar detection stuff. It's a project currently being looked at by the FCC and Ofcom together. Just a commentary of this. So there are spectrum issues which are improving, but my real question was, what about white space? Because there's bandwidth becoming available now as all of the TV channels are being digitized.
Yeah, that's. I mean, you know, other bands are definitely worth looking at. I don't know how much bandwidth is typically available in the white space bands, and by bandwidth I mean, you know, with the band. For the backbone network, you know, we have gigabit Ethernet circuits going, right, and so we're arriving in two places. So we would like sort of at least a sizable fraction of that available as capacity in the backbone network. Otherwise, it's kind of, well, you know, why are we doing that? And these links are fairly long as well, right? These are 10 kilometers, 20 kilometers. So yes, other bands. White space bands, great, if it will give the right capacity. It won't solve the tidal fading, though.
Multi-path MIMO will help there.
It will, yes. But I mean, at the expense of, you know, you can either trade off capacity or robustness. So you trade off some capacity to have the robustness, and yeah. Huh.
Okay, two more questions, and just to warn people that the fire alarm test is likely to go off at any minute.
Hi, Nathan Lassiter from Bytemark.
Yeah.
You going back to the shapes of the network, you had that slide showing that all of your communities were connected together, and then they were all also uplinked to hubs. How much kind of inter-community traffic do you see as opposed to traffic that's going out to the internet via hubs?
By volume, not much. By importance, because actually quite a lot, because it's people helping each other, people having a problem, not being able to debug this. Oh, can you help me? That sort of thing, and that's crucially important.
Yeah, Matt Wilson from IX Liverpool. It's just a quick question, more generally, really, about BGP. We've got two nodes, which is essentially just two switches within a short distance of each other, where we may not be able to connect fibre between them. I'm really trying to get advice on radio and BGP, because one of our ideas is to connect two switches or two nodes together, which are two separate sites, via a microwave radio. But somebody said to me recently, whatever you do, don't do or try to do BGP over microwave, because it just won't work. I just wondered your feedback on that.
Well, I mean, you know, routing protocols over potentially lossy links can always be problematic. I mean, you know, if you do something like the BFD, like the bidirectional forwarding detection, you know, you'll find that don't use the default timers, because they'll just give you way too many false positives and you'll tear your link down and cause all sorts of problems. If you can get a good link, it's good. If they're relatively close, you can do things in like the 24 gigahertz band, which is pretty quiet, doesn't have radar problems. We've got a link in our core network in Edinburgh that has been running at 24 gigahertz solidly for years. So I mean, we can talk about that more afterwards if you like. But there are. It is possible, but you need to be careful.
Okay, thanks.
Okay, one quick closing remark on this topic. You may recall, if you were at UKNOF35, that we had a lot of presentations about rural broadband and the challenges of building infrastructure in less dense areas. We've set up a mailing list for that now that we've got our shiny new Mailman server, which is rural broadband list. Steve Dyer's taking the lead on that. So if you're interested in subscribing to that list, go to the UKNOF Mailman server, and you'll see the list here, a chance to subscribe. Okay, thank you very much.
That's actually a great idea, because one of the difficulties is getting getting people talking together on a wider scale.
Yeah,
right?
no, we're not.
Yeah.
You know, we know there's lots of initiatives in this. We're not trying to preempt any existing activity, but if there's a place where people can share best practices and distribute
that's
clues.
Yeah, no, that's thank you.
Okay, thank you.
Yeah.